Alrighty, this is 1.6, distance tool number 1, and we're going to learn about the Pythagorean theorem, or review the Pythagorean theorem. I think many of you have already learned this before. Now, we're going to use the Pythagorean theorem as a tool, one of two tools we're going to talk about to find the distance between 2 points, or in other words, to find the length of a segment. So we're going to use it not so much in terms of triangles like you've maybe been used to, but in terms of finding a length. So I am going to remind you a couple things about the Pythagorean theorem. It is used for right triangles only. And remember, right triangles have a 90-degree angle within them. And it is maybe the most famous math formula of all time. It's this guy. A squared plus b squared equals c squared. And maybe you remember this. A and B are the legs of the right triangle, and C is the hypotenuse of the right triangle. Okay, and this is what we're going to be using every time. We're always going to be trying to find the hypotenuse. So the blue one, or what I color coded in blue, or C, is what we're going to be looking for each time. So I'm just going to draw a little picture here. I'm going to keep my colors going, and if you have colors that you can use that might be helpful to have in your notes, your legs are going to create that right angle. So we can call this one A and this one B, or we could switch them around. The order doesn't matter. And then C is going to be this long one that's always going to be found across from the right angle. So this guy here is C. C is always the longest side. Okay. I think that's all I really want to say about that. I think we'll just dive into an example. I think that's going to be the easiest way to explain it. So if you want to grab some graph paper, there should be some in the room. Just let me know if you can't find it, and you can just tape a piece right into your notes so you stay nice and organized. Or if you want to just sketch a graph by hand, that's totally fine too. But what example 1 says is find the distance between A and B. So you'll notice we have 2 points on the graph. We have a point A, we have a point B, and honestly, I don't even really care where they're located or like writing down the ordered pair. All I care about is finding this blue distance here that I just drew in. That's what we're looking for. So this is the C that we're looking for. Guess I could have kept that blue. Okay, and in order to find that distance, we can't just count squares because we're at an angle. So what we need to do is we need to create a right triangle. And there's a couple different ways we could do it. We could have drawn up here as well, but I'm just going to go straight to the right and then up. And then you can see we've created a right triangle. Now, we just need to count the squares on each of these sides, the legs. So 1, 2, 3, 4. That side is 4. This side is 1, 2, 3, 4, 5. This is A. This is B, or vice versa. It doesn't matter. And then we're just going to go back to our formula every time. A squared plus B squared equals C squared. I'm going to substitute those numbers in. So instead of A, we're going to put in 4. Instead of B, we're going to put in 5. And we don't know what C is yet, so we're just going to leave it. Okay, now squaring things. If you remember this from prior math classes, 4 squared really means 4 times 4. It means 4 times itself. So 4 times itself is 16. And 5 times itself, 5 times 5 is 25. And we're going to keep C squared. Okay, then we're going to add those together. 16 plus 25 is 41. So 41 equals C squared. Now, that's not our answer. Clearly, that distance is not 41 units long. We need to get rid of that square. So in order to get rid of a square, to undo it, you need to take the square root of both sides. Those guys are inverse operations. Some teachers will say those cancel each other out. I don't love that terminology, but it is what it is. That may be what you're used to. And at that point, we need to figure out what the square root of 41 is. So I recommend the Desmos calculator. You could grab a calculator from the classroom. You can use your own. That's just fine. But I'm going to use the Desmos one quite a bit. I'm going to slide this over so you can see it. It's desmos.com. I'm going to hit graphing calculator, click the keypad on the bottom, the square root button, 41, and it will show you the answer right there. We're going to round to 2 decimal places in this class, unless you hear otherwise. So I'm going to round to 6.40. Now this third decimal here is a 3, so we're not going to round up. We're going to, if it was 5 or larger, we would round up to 6.41, but it's not, so we'll stick with 6.40 as our answer. So let's write it nice and neat. C equals 6.40. Or what would be even better would be writing it like this. The length of AB equals 6.40. I like that answer the best. AB equals 6.40. All right, second one here, we'll just do one more. This time the points are not on the graph yet. They tell us where A and B are, and it's up to us to put them on the graph and then use the Pythagorean theorem to find the distance. So A is at -2, 4. That means go left 2 and up 4. Right here, that's where A is located. And then B is located at 3, -1. So to the right 3 and down 1. Remember, your X direction is always first. You're always going X, then Y. X is your left, right, and Y is your up, down, if you need a little reminder there. That's where our point B is located. All right, then I'm going to connect those. That's what we're looking for. That's the length we're looking for. I'm going to create a right triangle. So drop a line horizontally in each direction. And then we're just going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's fine. If they're both 5s, no problem there. We're going to do 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. 50 equals c squared. And then remember to take the square root of each of those. I'm going to hop on Desmos once again, find the square root of 50. And I get 7.07. Once again, that third decimal is less than 5, so we're not going to round up at all. And then I think the best notation we can use to write our answer is AB, or the length of AB, equals 7.07. And remember not to put a bar on top. If you put a bar on top of AB, that would mean you're talking about a picture, not about a length. And in this case, we're finding a length or a distance. So we can just leave it right like that. All right, so summary, couple important things that you may want to write down in your notes here. Step 1 would be to plot those points. Make sure you're being accurate with your plotting, otherwise you're going to end up in trouble. Once you've done that, connect those points, and that's what we're looking for. That's the distance we're looking for. Make yourself a right triangle. Label your legs A and B. Label the hypotenuse as C. And then use PT, or the Pythagorean theorem, to find the distance between the points. Okay, we're going to come back to the Pythagorean theorem quite a bit this school year, so this is one that you're going to want to make sure you have a good grasp on. And as always, if anything is a struggle for you, if any of the calculator stuff or any of the rounding stuff is an issue, totally fine, just let me know and I can help you navigate through that.